Now in this one, we want to look at some examples of polynomials and how we can graph them, what we can read from them. The first one, we want to be able to write the equation of a polynomial. We want to write the equation of a polynomial with zeros 1, 3, and minus 2 with a multiplicity of 3, a y-intercept of 0, 2. Please notice that the a I put there is so that we can substitute in the y-intercept and find in this case that a is equal to 24, or 2 is equal to 24a, so a is 112. Remember, that's going to tell us that we have got a vertical stretch or shrink. So there's our polynomial. We're not going to bother expanding it. Second thing we want to look at is, given the graph of a polynomial, determine as much as possible from that graph. Now in this case, the graph will have been drawn very professionally. Notice it rises to the left and falls to the right. Therefore, n is odd and a is less than 0. There we've got 3 zeros showing because we have 2 places where it is tangent and one where it crosses the x-axis. Now, the third thing we want to look at is, given the equation of a polynomial, let's see what we can do about sketching its graph. Because remember, we don't want to always rely on a calculator to sketch the graph. So the polynomial we're going to look at is that fifth order. Now I use the calculator here to factor it. Notice the factors are x plus 2 to the 4th times x minus 1. So I have a 0 of multiplicity 4 at x equal to minus 2. I have a 0 of multiplicity 1 at x equal to 1. So that gives me some major ideas. Right? Now, what else do we know? Well, we know that a is equal to 1, which is greater than 0. N is equal to 5. So, and that the y-intercept is minus 16. Okay, that gives us some definite information. We also know, since this is of degree 5, that it is going to rise to the left, fall to the right. Look at there. I'm right. It's, oh, terrible graph. Rise to the left. We're going to try once again to hit that y-intercept. Oh, not bad that time. Come up, and it takes off, crosses the x-axis there at minus 2, and takes off forever. Now, let's try this other one. Again, I used a calculator to factor it. And we have x minus 2 cubed times x plus 1. Again, a is greater than 0. N is equal to 4. We have a 0 at x equal to at minus 1 and 2. But the 1 at 2 is of multiplicity 3. Hey, very good. Let's see what we're going to do next with this thing. All right, we know some things like the y-intercept and so forth. And so let's see what we decide here. The 0 at 2 is of multiplicity 3. So notice we go in there. We happen to know, since it's a fourth order, we are falling to the left and rising to the right.